Sometimes it hasn't been recording my webcam, and sometimes it does, sometimes it doesn't. So we'll see if it does this time. So I'm going to do the daily 2, and the first one was, how do you know if a function is 1-to-1? And the function is 1-to-1 if it passes both the vertical line test and the horizontal line test, okay? So it has to pass both in order for it to be 1-to-1, all right? So that's the, so if the function is a function and its inverse is a function as well, then it's 1-to-1. And to know that, it has to pass both the horizontal line test and the vertical line test, okay? Actually, I think what I'll do is I'll share the screen. And then see if I have that daily 2. Oops, didn't want that. And see if I have that daily 2 up. Yeah, right here. So, so how do you know if a function 1-to-1? If it passes both the vertical line test and the horizontal line test. All right, number 2, the number of rings in the trunk of a tree determines its age. Identify the independent variable. Okay, the independent variable determines the dependent variable. All right, and so for this statement, the number of rings will be the independent variable. Okay, the independent variable determines the dependent variable. All right, okay, and so that's the answer for that. Any questions about that? Those, the independent variable determines the dependent variable. Okay. All right, well then I'm going to go ahead and continue going through the sample test. I actually want to share the screen because I have the sample final. Let's see, where do I have it? Right here. So I have the sample final here, and I want to continue to go through that. We have until 11:30, so about 20 minutes or so, should be enough. And we end off right here. Okay, so this is on page 4 of your sample final, if you would locate that. And so we have this. Now, we want G of, for number 3, we want G of f of 2. Okay, so f of 2, here's f of x. F of 2 is -2. All right, so what I want is G of -2. And G of -2 is +2. Okay, +2. So the answer for this is +2. All right. For number 4, this notation, what is this? What does this mean? Well, stop sharing for a minute. What this means, f of g of 2, this means f of g of 2. Okay, that's what this means. So I want g of 2, and then I want to take f of that. All right, so sharing once again, get back to our function. So here's g, okay, and g of 2 is 0. All right, and then f of 0 is -2. All right, so the answer to that is -2. All right, so number 4, the answer is -2. Okay, for the next one, all right, I'm going to write these functions down. 3x plus 5 for f of x, and g of x is x squared minus 1. All right, and then I'm going to go through this. I'm going to stop sharing. And so the first one to do is the sum of the functions, f plus g. And I can get that 3x plus 5 plus x squared minus 1. Okay. And then I can take all the parentheses away and just write them in descending order, x squared plus 3x, and then I have a couple like terms there that add to plus 4, and that's the answer to that. And then the reals, or the domain, are the reals. There's no restriction on the domain of this function. X can be anything. All right, next one is f minus g. And so I'm going to take f minus g. Writing that without parentheses, I get 3x plus 5 minus x squared plus 1. And then rearranging this so it's in descending order, negative x squared plus 3x plus 6. So that's that. And as far as domain goes, once again, there's no restriction. There's no radicals, there's no denominator, so it's just the reals. All right? Okay. Okay. And then the next one, f times g, is going to be 3x plus 5 times x squared minus 1. Okay. And then operating FOIL on this thing. First, I get 3x cubed, outer minus 3x, inner plus 5x squared, last minus 5. Rearranging that in descending order, I get this. And that'll be my answer. And then the domain, once again, would be the reals. Okay. And then finally, we want to take the quotient, f over g. So I get 3x plus 5 over x squared minus 1. I suppose if you wanted to, you could factor the denominator into x plus 1 and x minus 1. All right. I would take either answer. All right. And then as far as the domain goes, there is a denominator that cannot be 0. So I know that x plus 1 and x minus 1 cannot be 0. So that means that x plus 1 can't be 0, x minus 1 can't be 0. So therefore, x cannot be negative 1, nor can x be 1. And that would be the domain of this particular function. All right. And that does it for page 4. All right. Questions? Questions? All right. Okay. So on page 5, it says determine if g is the inverse of x. Well, here are the functions. Functions are f of x is equal to 2x minus 4, and g of x is equal to 1/2 x minus 2. Okay, as you recall, to figure out if they're inverses, we take f of g of x and we see if it equals x. If it is, then we have to test g of f of x. If that also equals x, both of those conditions must be true. Okay, if they are both true, then they're inverses. Okay, if either of them are false, then they're not inverses. Okay, so that's the test. So let's find out. Let's take f of g of x. I'm going to take g of x and we'll put it in here. So f of g of x is 2 times 1/2 x minus 2 minus 4. Minus 4, right? So distributing the 2, I get x minus 4 minus 4. Oh, well, that's x equals 8, x minus 8. And that does not equal x. So that means that they are not inverses. I don't have to test the other one, okay? I don't even have to test the other one. I know they're not inverses, okay? All right. All right. next, I'm going to actually take the screen again, and I want to go to that sample final. And so I did that one. Now, it says, all right, so here it says, find the domain and range of f. Okay, now the domain are the x's, right? So we come from the left, and it doesn't start until x equals -2. There's a closed dot there. So that means the domain is going to start at -2 inclusive. All right. And the function has values all the way to x equals 4 inclusive. All right. So the domain, if I was going to write this in interval notation, it would look like this: -2 to 4. All right. If I wrote it in inequality notation, I would write it like this: less than or equal to. Okay. That's the domain. Now, what about the range? Okay. What about the range here? Well, the range are the y values, right? So I come up from below. It doesn't start until y equals -3 inclusive. Okay. And it goes all the way up to y equals +3. So the range, I would write -3 to 3. And I would write it like this in interval notation. In inequality notation, we would write it like that. All right. Okay. Now it says sketch the graph of the inverse. Sketch the graph of the inverse. To do this, I identified ordered pairs. All right. I want to get a sketch. Now I know it's going to be the reflection about this x equals y line. Okay. But to plot it, I wanted ordered pairs. So I found the ordered pairs of the function f. And there's one, and that's the ordered pair is -2, -3. There's another one right here, -1, +1, and then another one over here at 4, 3. Okay. Now the ordered pairs of its inverse are just going to be these things flip-flopped. So this is going to be -3, -2, 1, -1, 3, 4, and that gives me ordered pairs for the inverse. Okay, and then I plotted that, and what I got from that was this. Okay, this graph right here. All right, this graph right here. So I got -3, -2 right there, 1, -1 there, 3, 4 there, and I just kind of sketched it, mirroring the original function about that line x equals y. All right, and then the range of the inverse. Okay, the domain of the inverse. It began at -3 and it ended at 3. All right. And the range began at -2 and it ended at +4. And note that for the domain and the range, they are flip-flopped from the function and its inverse. The domains and ranges are flip-flopped. Okay. All right. Questions? All right. I think we had one more to do. It said graph f. Okay. Now f, the function was the square root of x plus 2 minus 3. And you could graph this as like, this is a square root function that's transformed, right? 2 units to the left and 3 down. You could sketch it like that. I found ordered pairs. So I plugged in for f, I plugged in -2, and -2 plus 2 is 0, square root of 0, and then -3. So I got that as one of my points. I know 1 is a perfect square, so I can get 1 by putting -1 in for x. -1 plus 2 is +1, right? negative 1 plus 2 is positive 1. Square root of that is 1. Minus 3 is negative 2. So I got points like that. And then I know a perfect square is 4, so I put in 2 there to get 2 plus 2 is 4. Square root 2. 2 minus 3 is negative 1. So I got some ordered pairs just to guide me on drawing that graph. Okay, and it led me to the graph. Okay, and then it says find F1. Well, let's see. I need another sheet of paper for this. So, well, no, I won't. I'm going to cheat and kind of go right over here. Save paper. So I'm going to flip out the coordinates and say, okay, x is equal to square root of y plus 2 minus 3. And I'm going to solve that for y. All right, so I'm going to bring the 3 over. X plus 3 is equal to root y plus 2. I'm going to square it. I'm going to square it. And then subtract the 2. And I get y is equal to this x plus 3 quantity squared minus 2. And that's the inverse. Okay. Add the graph of the inverse. So the inverse, once again, is going to be the coordinates that are switched, like that. Okay. All right. And then graph it. And then find the domains and the ranges. Okay, well, so here's what I got. Okay. So here's my inverse, right? And here's my original function, f of x, mirrored across x equals y is going to give me a function like this. Okay. All right. The domain of the original function, okay, starts at x equals negative 2, okay, because that radical, can't see that. This radical, no, it's not right either. That radical restricts the domain to so that x plus 2 must be greater than or equal to 0, right? And that means x is greater than or equal to negative 2. So the domain begins at negative 2 and it goes to infinity. Okay. So this function begins at negative 2 and goes to positive infinity. The range began at negative 3 because at the first point of domain, negative 2, the value of the function was negative 3. So it starts there and then it increases to infinity. Okay. For the range, I said that, never mind. And then this is the inverse, the domains and ranges are flipped. So you can see the domain for this function begins at negative 3 and it goes to infinity. And the range begins at negative 2, which is hard to see in my grid because the grid didn't show up very well on this printout. It goes to infinity there. So their domains and ranges are flipped. All right. And that was the sample final. Okay. All right. Do you have any questions for me? The final exam is going to look very much like this sample final. Okay, it's going to be in the form of a PDF that you'll have available at the beginning of class. You're going to download it, print it, or write it on your own sheet of paper and then submit it. Okay, and there will be a deadline for the time. Now, for this class, this class begins Wednesday at 10:35. All right. If you want, you can get here a little bit early. Okay, I'll open up the test at 10:30. If you can start at 5 minutes early, and then I'm going to give you until 12:35, which is actually 10 minutes past the end of class. I'm going to get till 12:35 to get that scanned in and submitted to Schoology. All right. Okay, it's 15% of your semester grade. All right. Anything that is missing, and I know I got stuff done. I got emails over the weekend. I didn't get to all of them, but I will hopefully by the end of today. Any stuff that's missing needs to get in by the end of today. By the end of today, Monday. All right, and please don't email me at 10 o'clock asking for a mastery check. Okay, do that because I'm very well might be off my computer by then. So any mastery checks that you need, ask me early in the day, like now. Okay, and then I can get those to you, and so you can get them in by the end of the day. All right? Questions?
Mr. T,
Yes.
if we if we don't like print it out, do we have to write down the questions?
No, you don't have to write down the questions, but be very clear which question you're answering, you know? Go in order. Write down the number of the problem at least, 17, 18, stuff like that. And please do it in order. Don't jump around. Okay. But if you have printer issues or whatever, I understand. Okay, just make it easy on me. Okay. Yeah, don't confuse me, because otherwise I might not award the points that you deserve. Okay, so try to make it as clear as you can. Anything else?